I want you to look at the chart, the table. Remember, in a table, the first column is X and the second column is Y. X is always independent and Y is always dependent. So the first difference is you would calculate by subtracting the dependent variables. Okay, and you go from the bottom to the top. So they did the first one for you. 2 take away 1. Now this only works, it gives you the answer when the independent variables change by a constant amount as well. Okay, if both variables are changing by a constant amount, you automatically know the relation is linear. Remember we talked about this? The rise and the run must change by the same amount, otherwise it's not going to be a straight line. Right?
Yes, for the constant.
Okay, the differences are constant and would be equal to the rise in the rate of change. Okay, so we're going to complete the table comparing the step number, and we're using this diagram here. And the number of circles in the base. Okay, that's what they're looking at. So for step 1, how many circles are on the bottom? 1. Step 2, how many circles are on the bottom?
2,
Step 3, how many circles are on the bottom?
3,
Step 4, how many circles do you think will be on the bottom?
4,
And
5,
good.
6.
Okay, find the differences between each of them. The first one's done for you. You are subtracting every single value from each other. 2 minus 1. Then we're going to do 3 minus 2.
I get it.
That's it.
5 minus.
Oops, equals 1. Then 4 minus 3, don't skip them, equals
1.
1. And then 5 minus 4 equals,
1.
okay, very
Oh
simple.
my gosh, I'm so smart.
The first differences are all 1. The first differences are 1, positive 1. Look here, please.
Yeah, we are.
Remember I told you that the first column is X and the second column is Y. So when you graph the first table, you're using these as coordinates. We have 1, 1, then 2, 2. These are all the coordinates. 3, 3, 4, 4, and 5, 5. Try to use 2 different colors. I'm going to graph this with blue, and then I'm going to graph the second table with a different color. So now we're looking at the step number. I just redrew it here so you don't have to keep flipping back and forth. And the total number of circles this time. So in the first step pattern, how many circles are there altogether?
1,
In the second one, how many circles are there? 1, 2, 3.
3,
Come on, people. In the next one, how many circles are there? 1, 2, 3, 4, 5, 6.
6.
I want you to fill in the rest on your own. See if you can figure out the pattern. Okay, so step 4 had 10 circles and step 5 had 15. Now I want you to calculate the differences. The first one you leave blank. Do this. Okay? Shh. And then we're going to do 3 minus 1 equals
2. I get it.
6 minus 3 equals. What do I subtract next?
10 minus
Good. 10 minus 6 equals. And the last one, 15 minus 10 equals. Okay, now in this question, were the first differences the same?
Yes.
No, there's
Oh,
2,
two.
then 3, then 4, then 5. In the first example, were the first differences the same? So in the first one, it means that it's increasing by the same amount every single time. Do you think the first table would be linear if you were to graph it?
No.
If it's increasing by the same amount every single time, is it going to be linear?
Yes.
Yes. The second table, it's not increasing by the same amount every time. So do you think it's going to be linear or nonlinear? We're going to graph it and see, okay? We're going to figure out which one's linear and which one's nonlinear. We're graphing both relations. Let me show you how to graph this. I'm going to use pink. So my first coordinate is 1, 1, and then my second coordinate is 2, 3, 3, 6, 4, 10, 5, 15. I'm going to graph that using pink. So we're doing step number on the x-axis and total. I'm just going to write total because the first one is total number of circles in the base, and the second one is total number of circles. Okay? 0, what would be a good scale for x? What is x increasing by? 1, sure. 1, 2, 3, 4, 5. We only go up to 5. And then, what should we use for the y-axis? What scale? What do you want to count by?
1, 2,
We need to get up to 15. So do we have
5.
room? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't have room to count by ones. I'm going to count by twos. 2, 4, 6, 8, 10, 12, 14, 16. And I want you to now graph both lines. So I graphed the first table. It should look something like this. Is it a straight line, yes or no? So my first table, so table 1, which was question number 1, is linear. I'm going to graph the second one. If the first differences are not the same, it means it's not increasing by the same amount. Do you think it's going to be linear?
No.
Let's graph it. 1, 1 is the first point, and then 2, 3, and then 3, 6 is up here, 4, 10, 5, 15. That's the second table. You should have a curve. It's non-linear. Table 2. How do I know? Is it a straight line?
No.
No, it's not a straight line. If the points on the graph do not form a straight line, it's not linear. Is the linear pattern, so the one that was linear, is it direct or partial? The one that was linear. Direct, why?
Because
It started at 0, 0. If you extend the line, it will start at 0, 0, okay? So write a rule to show how you can use first differences to tell you if the relation is linear or nonlinear, and I just explained this. If the first differences are constant, that means if they are the same, then you automatically know the relation is linear. Okay, we did the two tables. If the first differences were all the same number, we knew that it's going to be linear. If the first differences are not the same, so you can say first differences are not constant, then it's going to be what? It will be, thank you, non-linear. Okay, that's important. So we know that this is also important. I want you to copy this down. How are the first differences and the rate of change related? The first differences equal the rate of change. It tells you what the relation changes by.